Hello, everybody, and welcome to Unit H. Unit H is on key value databases with emphasis on the Redis key value database. You're going to see that Redis will do a lot more than key value, but we'll start by just looking mostly at key value. All right, so what's on the agenda? What's key value? We'll take a look at the Redis architecture. Then we'll look at all the different types of data structures that Redis supports, starting with strings, then moving on to hashes, and then lists, ordered sets, and then getting into how Redis does streaming with pub/sub. And we'll have lots of demos along the way, of course. First, let's talk about what are key value databases and how do they work, etc. So at its essence, a key value database sounds a heck of a lot like what it actually is. Key value database stores data under a key. The key is most likely globally namespaced. For example, customers, and then this would be the ID of the customer, then shopping cart, and then this would be the instance of the shopping cart. And data can only be retrieved by key. And because of this, we need to be responsible in the way that we name our keys. We have to make sure that there's no duplicate keys in our key value store database. What can you store under the key? Well, really anything you want. So you can store a value. You can store a blob. So one of the string values that you can store is the entire contents of a web page if you want. You can store an image or video. You can store a data structure. So you can, rather than storing maybe the value is a list or a hash or a queue or a stack that you can then perform operations on. You can also store just flat out XML and JSON. So in this regard, key value ends up being like document. How does it differ? Well, document allows you to manage collections and build indexes, and key value doesn't have any of that stuff. Okay, key value does not have any concepts of indexes or anything like that. It's just not the way that it was designed, and it's not the intention of it. Again, consider key value to be a special purpose kind of database. It doesn't really sort of model just everything under the sun that we would possibly think of. Although you're going to see in some examples that if you embrace the behaviors of key value, you can really make some very interesting applications and solve a variety of problems with key value. Okay. So let's talk Redis. Now, Redis is officially, even though it's in the category of key value, the Redis defines itself as a persistent data structure store. All data is stored under a global key, but the values are complex types. They don't have to just be strings or blobs. They can be a variety of different types. And all operations that you perform on Redis are, they take place in memory and then are asynchronously spilled to disk. And this creates for a database that is of incredibly high performance. So one of the things that everybody likes about Redis is just how amazingly fast the reads and writes are. Redis supports a dual architecture. It will function as a CP or AP system. You can set it up either way. You can set it up to be single master to guarantee consistency, or you can also set it up to scale horizontally and use a eventual consistency system. So there are a couple different ways that it can be architected. And then as I've already alluded to with the concept of key value, Redis has a flat data model. It has a global namespace, data store under a global key, and it has a very simple query language that is not at all, it doesn't even look like SQL. So why would you use a database like this? There's many use cases for Redis. You can use it as a session store, that is to keep track of people who are logged in. So imagine you have a web farm of hundreds of servers located all across the world, and you want to store session globally you wouldn't want to store session on the web servers, because then the session is tied to the web server that the user's logged into. And if they log in from their website and then later on they log in from their phone, you want to make sure that it's still the same person. So you can store the login information in a scalable Redis database. You can also use it for page caching. So if it takes a lot of effort to build the web page, what you can do is in the middle tier of your application, in the business logic layer, you can have something that generates the page and then stores it to the cache in Redis. And then when someone makes a request to the web page, you give them the page out of Redis rather than redrawing the page. And you can set a timeout in Redis for how long something like this would live, like a time to live. And this is incredibly efficient to save on CPU processing. Like if someone goes to a page that requires a lot of effort to build, storing it in a cache like this makes a heck of a lot of sense, especially if the data isn't going to get stale for another 24 hours, for example. You can also use it to build out message queues. So you can have a pub sub model where one service pushes messages to the queue, and then another set of services would read the messages from the queue. You can create dashboard and leaderboards in Redis. So imagine you want to roll up some analytics and then put those somewhere on a screen. It won't help you get it on a screen, but it will help you keep the statistics of those analytics available and efficiently capable of being retrieved. Like I said, you could do pub sub messaging, so you could build like a chat app in Redis. You can also use it to delay execution of long-running processes like sending emails. And it also will do some geolocation math for you. So that's another nice feature of Redis. Okay, there are two Redis persistent architectures. One of them is called RDB, and one of them is AOF. AOF is, well, they both have the equivalents in relational. So RDB is like the database file itself. It gives you a point-in-time look at what's happening in Redis. So when the Redis data spills over to the RDB, what you see is the last time that data was written. That's what it looks like. You don't have any kind of what happened 5 minutes ago thing looking on. That's kind of what the AOF does. So if you configure Redis to do RDB, you won't be able to look at what the data looked like, 3 hours ago, but you will always have a current look at what the data is, right? So this is a very consistent snapshot of the data. On restart, the data is loaded back into Redis from the current state. So the AOF is more like a commit or transaction log. Every change made to Redis, that is stored, and then this will grow over time and get larger and larger over time. And then on restart, we replay the AOF to build the current state of the database. So this is kind of like what we call event sourcing, AOF. You're not storing the state of the data, you're storing the changes that lead to the state of the data, whereas this one stores the state of the data. This is a much faster and more simplistic model. This is the kind of model you want to use if you need to be able to rewind time and put Redis back to the way it was n seconds ago or n minutes ago or n days ago. You would need to use this AOF format. So, RDB, you do some kind of change to Redis. At some interval, it just dumps the current state of Redis to a file. That's how RDB works. When you're using AOF, you do some kind of CRUD in Redis, and each CRUD that you do, like I do an update, I do a delete, I do a create, each of those transactions, those steps, are appended to this AOF, this append-only file, and then the end of the append only file, if I replay all those transactions, I have the current state. So if you go here in the AOF, you'll have the state at that point in time. If you go here at the AOF, you'll have the state at that point in time. Again, this is very familiar to you. This is how a database transaction log works. This is how a database file works. The difference is that Redis stores everything in memory and then just periodically dumps the data to the RDB. Every change made in Redis still has the current state in memory, but every change made to Redis is dumped to the AOF. So both give us persistence, yet still take advantage of Redis's amazing ability to be able to store everything in memory so that the operations are incredibly fast. As we mentioned before, there are two modes. So not only are there two storage modes in Redis, but there are two operational modes for the cluster. The cluster could be Sentinel, or it can be cluster. Sentinel, it has consistent reads, and cluster has eventual consistency. So you get to choose in Redis how you want Redis to behave. In a Sentinel system, we have a master, because all CP systems are single master, some way, somehow. And you would make requests to the Redis master, and then it would send copies to the replicas. And sometimes you might talk to the replica to get your information back out, but that would be governed and orchestrated by the master. So again, this is another high availability solution, single master architecture. It gives us consistent reads because when we want data, we ask the master, and the master will figure out where the most consistent piece of that data is. All data are replicated under this. There are no shards. So you do not get like the MongoDB type of model where some of the data is stored here and some of the data is stored there. That's not how this works. Okay. If you want, you can take your Sentinel system and implement it in a AP environment by doing this. So if I take and have multiple masters, and each master is responsible for n replicas, in this case, each master has one replica, but I could have each master have 3 replicas, then these masters talk to each other in a peer-to-peer like fashion in the same way that they would work with Cassandra. And the data can be split evenly across the nodes through a hashing algorithm. And then the shards are replicated asynchronously. And again, there's no single master here. There's multiple masters. So if I write to one key, it may always write here. If I write to a different key, it might write there. And then this data set here gets replicated somewhere. And then this data set here might get replicated somewhere. So in a way, it works a lot like Cassandra does. Again, this gives us eventual consistency, but no immediate guarantees of consistency. Okay, let's dive into all the different types of models that you can build with Redis. Okay, the Redis data model, all keys live in a global key space. You can have multiple databases, but that's not cluster friendly and should be avoided. So by default, you have one database, one global key space. Keys can be anything you want. All of these are valid Redis keys. 100, a bunch of underscores, the word set, which is actually a reserved word, and this in quotes, this is a key. So because you can name anything you want a key, there are best practices or conventions that we should use when building a key, and they are to semantically namespace your key. So, for example, instead of just mafudge as a key, I provide semantics around what mafudge is. I would say like session user mafudge. So that tells me that mafudge is an instance of a user session. And for example, if I take the about page and I cache it, I might say web : page cache : and then this is the URI to the page that I'm caching. So those are great examples of how to semantically namespace something. And its convention is to use the colon symbol to separate the items in your global key. You can use whatever you want, but everybody else in the world uses this colon. Again, you're responsible for key management, and you can only retrieve a value by its key. Redis is more than just key value. It's actually a full data structure database, and it has some unique data types which provide for a variety of data-oriented activities. We have strings, arbitrary textual data. This can represent binary data that's been encoded as a string as well. You can do hashes, which are sets of key values. Think of these hashes as rows in a table. So if I have a hash, I can have customer name. I can have a global key, customers, and then colon ID, and that's the primary key of the customer. And then I can have name, and then that's a hash key, and the value is Mike, and then email, and then the hash key, and then the value is mafudge@CREDU, and then et cetera, et cetera. And those are all fields that are associated with that one customer ID. So you can actually kind of build a table in Redis using hashes. And the proper way to name keys. Lists are really neat. You can build collections of strings or anything. And then the values that you retrieve out of the list can be retrieved from either end. So it can function as like a queue or a stack. So if you wanted to build some kind of queuing mechanism, you can use a list to do that. If you wanted to build some kind of LIFO, last in, first out stack, you could do that as well. So this is a really great thing because a lot of times what we do is when we're programming an application, we need a stack or a queue, and we code it in RAM. And I know this isn't really a concern of IST769, this course, but I just want you to hear me out for a minute. So you're coding an application, and the application needs to store stuff in memory. And that stuff in memory is stored in a list or it's stored in a queue. Well, if you store it in memory, then it doesn't scale horizontally because your application, if I log in, and I get host A, and then I log in later and get host B, then my list is not going to be in RAM on the same machine. So if you use a Redis list for that, and if your app asks Redis to manage the list, and the Redis server is independent of the host, you're now taking the data out of your application and then making the code you write more immutable, right? So think about that. We don't store any real variables in our Java code or our C# code or our Python code that change. We store those in Redis instead, and that leads to giving us this immutability that allows us to take that same code and deploy it hundreds of times and not have to concern about scale because the data is not really even stored in the application. The data is stored in Redis. So we use Redis as this global namespace to store our data. And when you get into a mindset like that, as a programmer, you can be really jazzed about Redis because now all of a sudden it makes it really easy for you to build an app that's going to scale horizontally and not have to rethink your design. The only thing you need to think about is if I'm storing something in memory, is that immutable? That is it not going to change? Okay, continue to store it with a variable that I make. If it is going to change throughout the course of the app running, then I want to store it in Redis instead. That's basically the idea. So that's why we have things like hashes, lists, and sets that can be used in Redis. These are ways to manage complex structures of data and not store them with the code base that we write, but store them in a data structure server instead that we can access from any instance of that code base. Okay, how about our first demo? Let me get my head out of the way. There we go. How about our first demo? This first demo will show you the Redis Commander GUI, and we'll add a couple of keys in there, and then we'll view the hierarchy in Redis. Then we'll connect to the Redis CLI and do the same thing. We'll connect to the Redis command line and do exactly the same demo. And in this process, I'll show you that, there is no rules with Redis. You can store whatever you want. And this is probably why you are going to really think about Redis for very special purposes and not building a generic application, unless of course, you're a developer. If you're using a developer, where you might have used a relational database as your persistent storage, you're like falling in love with Redis, because Redis stores your data and you don't have to worry about the mapping of your application's data to the relational model, which is something that is non-trivial for a software developer to do. Now, they've made this a little easier to do for people, but in reality, it's exciting to be a programmer and know that you can just take data and store it somewhere and know that it's always going to be there for you, and not have to worry so much about adding it as a row to a table or querying it out with a select statement. Okay, let's get into the demo. All right, I'm out here at Redis Commander, which is a web-based UI to Redis. I find it convenient to use when I just need to poke around and see what I've got in Redis as I'm developing an app for Redis. There's also a little command line down here where you can do things like keys and get all the keys, right? See, there we go. But we're just going to poke around in the GUI here in Redis Commander. And when we want to use the command line, you could actually go down here and use the command line, or you can use the shell command line, which is here, right? And then from this guy, you can do docker compose exec Redis. On the Redis container, we want to access the Redis command line. And then that takes you in here. And now I'm in the Redis command line. Get all the keys. Okay. So let's start out in Redis Commander again. We're over here. And what I'm going to do is I'm going to make a key here. And let's just call this like person. And then this is Bob. And then Bob is just going to say, my name is Bob. And you'll see now that there is a person folder, and then in the folder is Bob. And that's because by convention, when you use a colon, it will separate out your namespace. It will add a hierarchy to your namespace for you. So if I add another key here, let's just go here, add a new key, person. See, it assumes person because I'm in the person folder. Let's put Dave in. And then this string is going to be some JSON. Name Dave, then age 25. We'll validate as JSON. Why the heck not? Okay. Now, it doesn't matter. They're both strings. See that? String. Doesn't matter. So you can store whatever it is that you want. So what's nice about this is if you use Redis to store your data, then you can even store just simple variables in Redis. And then those variables will be spread across your application. So if your application, has two nodes in it, and one node reads Dave or Bob, it gets back, my name is Bob. If the other node reads who's Bob, it gets back Bob. If one node writes Bob and says, the answer to, the value of Bob is 56. The other node says, hey, read the value of Bob, and it comes back and now it's 56. So this is a way that you keep data consistent across more than one instance of the application, is to use a global data structure. And a key value is perfect for this, for this type of thing. So that's how the keys work. And if I may, now if I go to the command line, I can do get, and then I can say, what was it, person? I'm sorry, keys. And those are my two keys. Now I can't get multiple keys. I can say get person Bob, and I get 56 because that's the value, or I can do set person Bob to my name is Bob. And then I can get person Bob again, and now it says that. And then I can also say set or get person Dave, and I get back some JSON. Okay, and it's been formatted as JSON. So if I read this into Python, I can easily deserialize this into a Python object quickly and easily. So again, this is what makes Redis so awesome. Just so easy to take something and save it, but also save it so that other parts of your application can get it. And this is where you start to learn to decouple, the pieces of your application from each other so that you can get things to scale. And that's really kind of the idea behind what Redis can offer us. So that's it. Basically, keys and values, getting those keys and values. You can see that there's other keys that I've added in here for different things, but that's other stuff that we'll see later on. You can also add to any key, right? I can go here and then add a new key, and I can pick a different type. I can pick a hash and then say person Mike, and then I can say the field is name and the value is Mike. Right? And then I can go back to this person Mike and see it's a hash, it's got a pound. And then I can add another field, and maybe I'll add age and, I don't know, 51. Right? Now let's go back to the command line, right? If I go back here and say get person Mike, it says it's the wrong type because get gets strings. So I got to use hget, right? And then I have to say which field I want to get out of Mike. Do I want to get name or age? Name. So the different, and I know we're getting ahead of ourselves here, but the different types of data have different commands to retrieve the information back out from the data store. So this is the key to understanding Redis, is understanding that there's different ways that you can peek and poke at the data and get that data out and use it. Let's take a closer look at Redis strings. So we use the Redis strings to really store whatever we want. You can store text, HTML, JSON. You can take any binary and what's called base64 encode it, which takes the binary version of it and represents it as text so that you can, when you base64 decode it, it ends up looking like the picture that it originally was, or it'll play back as the video that it is, or it runs like the application that it was. Now, there is a limit here. You can only store, under a key, you can only store 512 megabytes, which is a half a gigabyte, which is a pretty damn large value, okay? Honestly, if it's bigger than that, it's probably an incorrect use case for Redis. Maybe you want to use object storage instead, right? So you could use something where instead of storing the object itself in Redis, you store a key, and then under the value is its location in object storage. And then that way there's an extra step to retrieving the data. Is you retrieve the key gives you the value tells you where to go into min.io to get the thing that you're looking for. It's not ideal, but it's how you would probably get around this half gig limit. What do you store? Things like atomic data like name, email, phone number, contents of a web page, output from a database query, the database query itself, base64 versions of photos or other binaries, code. Lots of stuff. Anything can be stored in a Redis string. here are the commands that are used in Redis strings. Let me get my fat head out of the way. So we have get and set, which we saw. mget, mset, those allow you to set multiple keys and values. So imagine you are on your, let me put my head back on there so you can see me gesticulate. So imagine that you are in a Python program and you have 6 variables and you want to write all 6 variables to Redis and you want to do that in one trip. So the way you do that in one trip is you use mset. So in mset, you can send all 6 variables to Redis to be written. Much easier than doing set, and sending 6 of those over the wire. So that's why mset and mget exist. Okay, likewise, there's exists to see if the key if there's a key there already, and then there's get set, which is kind of cool. It get the current value, then set a new value. So it's a way to read a value and then put a new value back in there in the same time. One operation. There's also some other commands here as well. Del will delete a key. Keys let you find keys. Type gets you the type of value under the key. P-expire will set an expiration pattern on a key. Persist will save the value immediately. It will push the data to disk instead of waiting for the spill to disk time to hit. And flush all removes all keys from Redis and all the values. Cool thing about keys is you can automatically set a time to live on them. So you can say set, X test, and then you can say expire X5. So we're setting the key X to test. Then this says expire key X in 5 seconds. Or you can do it all in one line where you say set X test X5. And that says set the key X to the value test and auto expire in 5 seconds. So let's do some demos of these strings that you can do. And what we'll do is we'll show you how to do some page timeouts and multiple sets and gets and all sorts of stuff like that. Okay. And just give you a sense of how to do some things in Redis and also think about the kinds of things you might do in Redis. All right, I'm out here at the Redis command line, ready to type in some Redis commands. So let's do, you saw some gets and sets before. Let's do this. Let's do get, let's do set person. Let's do, we already have, let's do keys person. And what do we got here? And there's a mic person, right? So let's delete that. Del person mic. See, I can also add another one, person, fudge or whatever. But let's just delete me out of there. And then let's do a mset. We're going to set multiple keys and values. So we're going to set person, mic, and then the value is going to be this is mic. And then we're going to set another key, person, Sue, and then the value for this is going to be 123.45. Doesn't matter what the values are. Okay, done. I set 2 keys at once. And then I can mget. Let's get mget. I wish I could do person star. I can't. Can't do that because it thinks that person star is an actual key. Because anything can be a key. You can get a key. You can have a key called star. Okay, that's a bad key. Don't do that. Right. So I can do mget person Mike, person Sue, person Dave. I got all 3 of those keys. So how do you go about getting all of the values under a key? Well, one of the tricks there is you would store each of these values namespaced under another key, person. And so we haven't learned that data structure yet, but I'll come back and show that at some point. But that helps you manage which values are associated with this key person, with this super key person. And then these are the like the primary keys or the business keys under there. It helps you manage that a little better so that you know who all of them are. Now, yes, you can do keys, right? And then person star, and then that tells you which ones to retrieve, right? So if you're writing an application, step one is do that, you get back this, then it becomes mget. Operation 2 is mget all of those. But you can't say mget and then pass into the mget like keys person. That doesn't work. That's not how Redis works. Each one of these steps is like atomic and has to happen on its own. So you have to do keys person, send that back to your app. Then your app would in turn send back to Redis mget person Bob, person Dave, person Mike, etc. Then your application would send that to Redis, and then Redis would give you back this. And then you'd have your data. So it's like a two-stepper, but they're two incredibly fast steps. So I wouldn't be so concerned about the fact that it's 2 steps. So we can also use exists. So I can say exists, and I can say person Bob. And it says 1, and I say in person Alice 0, right? 1 exists, 0 doesn't exist, right? True and false. You can do let's do like an example with page caching. So let's suppose I do set web URI. Let's do a full URL, web URL HTTPS iSchool CREDU, and then the value would be the contents of the web page as HTML. Okay. And then if I say keys web URL, I get that. I spelled iSchool wrong, but what else is new, right? And then if I said get, right, I can get that key, get, you want to watch me type it, so I can get that key, and then it would give me back the web page. This would be the contents of the web page as HTML. I just put in some text. If you're going to build like a page cache, you can set a timeout. So, for example, I can say, let's say set web URL iSchool CREDU, and then let's expire that in, I don't know, 5 seconds. And then I can get it, and it's there, and I can get it again, and it's not there. It's not there the second time because it expired. So this is a beautiful thing you can do in Redis, is you can set these expirations on these keys so that they just go away after a certain amount of time. They auto-delete themselves. And this is a really useful use case of Redis. All right, let's explore Redis hashes now. Redis hashes. So a hash allows you to store several fields under a single key. So this is very similar to what you might see out of a database table row or a wide column store, right? It's actually more similar to a wide column store than it would be a database table row. No scheme at all. Hashes with a namespace key are treated as tables of data to Redis clients, such as Spark, and to all the other libraries that I've used with Redis. So hashes allow for several fields under a single key. So you have hset, key field value, or hmset for multiple fields and values, key field value, field value. And then you could do an hget and an hgetAll to get all the values under a key. And then an hmget if you want to get multiple keys and values, but not all of them. And then hExists to find out if a key is there or not. All right, so let's do another demo, and this demo will use hashes instead. All right, I'm back out here at the Redis command line, and let's play around with some hashes. So one use case of a hash is when you want to store multiple values under that key. So a good example of that is maybe you're building out a session key for like a web, e-commerce website. So I can do set session, ma_fudge is a session, and then I can say name of the person is, I don't know, Michael Fudge. So one of my keys is name. All right, and then I can do hget, and then I don't have to give it a value. I just give it the key I want to get. hget. Then I get the value Michael Fudge. Now I can also set multiple keys. I could do hmset. Under session ma_fudge, under the same key, let's put credit limit. That's a key, and the value is going to be 500. And then let's put in IP address. It'll be 10.1.2.3. And then let's put in browser, and let's put in Chrome. All right, I just set a bunch of keys. So if I do hmget, I can get from session ma_fudge, credit limit, and maybe name. Credit limit 500, name Michael Fudge. Or I can do hgetAll, session ma_fudge. And I get all the keys and values. So let's add another session just for grins here. So let's add another user session, hmset session J Jones. And let's do name Jen Jones. And Jen Jones only has an IP address of 10.145, and then mobile, and that's going to be true. All right. If I hgetAll session J Jones, right? Oh boy, it's session. I used the wrong key. See that? This one says session. This one says sessions. So that's a boo-boo, right? And that's easy to do in Redis. So del sessions J Jones. Let's del that. Del that. When you're responsible for the keys, you can make all sorts of mistakes. That's right. So if I do keys session, there's my two sessions. One's for J Jones, one for ma_fudge. So if I wanted to query all the sessions, I would first do keys session. Then my app would return this. Then I would do hgetAll, session J Jones, right? And then ma_fudge. And my app would get back a column name for both, a column IP address for both, a column mobile for J Jones, which is true, and then for ma_fudge, that would probably be null, and then a credit limit for ma_fudge, and for J Jones, that would be null. So you can tabularize the hash data if you want. Again, it's in Redis, everything is a two-step process. First thing is find out how many you have, and the second thing is to retrieve them all. With hashes, you have to issue multiple gets to get them. One for each row, which is not unlike what you would do in a relational database, only that's being done for you when you type select. Okay, so don't freak out by the fact that you're making multiple trips, reads and writes back to the database. A lot of that is happening anyway. And remember, Redis is all in memory, so it's much faster. Very little of it, none of it really has to go to disk. It's not designed to do that. Okay, let's talk about Redis lists. Now, a list is exactly what you think of. A to-do list, shopping list, laundry list. That's great, but you can also use lists to build data structures, specifically stacks and queues. And a stack is a list where we only put things on the front or the top of the list, and we only take things from the top of the list. So imagine a stack as a stack of books or a stack of plates. You can't, if you put a plate and then another plate and then another plate and another plate and another plate, when you go to remove a plate, you can't remove this one. You got to remove them from the top. So first or last in is the first out. So this was plate 1, 2, 3, 4, 5. They get removed 5, 4, 3, 2, 1. Last in, first out. Okay. That is different than a queue. Think of a queue as waiting in line at the bank, right? People show up, waiting for the teller, 1, 2, 3, 4, and they get served back out 1, 2, 3, 4, 5. Okay. So as you come in, you wait in line or online, depending on where you're coming from. And once it's time for you to be served, you come out of the queue. So we usually call this pushing and popping. This is not called pushing and popping in queue nomenclature. It's called arriving and serving. But the way it works in Redis is you do an L push, L pop, you get a stack. If you do an L push, R pop, you'll get a queue. Yeah, there's an R push and an L pop. But, again, when you want to think of stacks, L push, L pop. When you want to think of queues, L push, R pop. Okay. Here's the Redis commands. You get LR push, LR pop. Okay. When you push, you can push multiple items. You can L push and then push 5 items if you want under that key. L range will give you all of the items. If you say L range 0 - 1, it gives you all the items. If you say L range 0 2, it'll give you the first 3 items, 0, 1, and 2. If you L push, it will add to the beginning. If you L pop, it'll remove from the beginning. If you R pop, it removes from the end. And then L len tells you how many are in the list. And L index will tell you the position of the value. Okay. If the value's in the list. Okay. So we'll demo a few of these next. Okay. So here's a demo that we're going to do. And we'll just do some simple list examples just so you get an idea of how a list works. And then after we get a good idea how the list works, we will go ahead and build this work queue where we push messages into the work queue, and then one or more of our receivers will pop them off the work queue. And this is incredibly useful with Redis, because what you can do is you can have, like, this work queue can be maybe sending emails or text messages, right? What you don't want to do is tightly couple that in your application. So you can write a Python app that says, as a button says, send a text message. You click the button, and the only thing that happens is it sends the information to the work queue. And then another app running in the cloud just reads the work queue and says, oh, time to send a text message, oh, time to send a text message. And then you've decoupled the sending of the text messages from the app that you're using. And it's important to do this because then you don't incur some crazy dependency that must be in your app. You know, the code that sends the text message would have to live in your app. And if you architect it this way, it doesn't have to. And you can make you can build what's called a microservices architecture, where you just write programs that do simple things like send emails or send text messages or whatever. And then your app can just be responsible for pushing things to queues to get work done. Okay. You're going to see later on this idea gets taken to the extreme with Kafka. The whole architecture behind Kafka is to build distributed work queues. Okay, on with the demo. Alrighty, let's be a little simplistic with our first list example. Let's do, the hello world of lists, the shopping list, right? So I'm going to say L push shopping list. And then I'm going to push apples, beer, diapers. And I'm going to do L range and then I'll do shopping list, and then I want 0, -1. And that's all the items on the list, 0 to -1. Now, shopping is a horrible key name because in true Redis, there would be a shopping list associated with maybe each user that logs into the database, right? Or maybe it's each list type. So if you were really, let's suppose you're building a list management app on a phone, and like a to-do list management app on a phone, then your Redis key space would probably look something like this. It would be, to-do, user, and then the user ID, and then list type, and then list name, and then the name of the list, right? So this might be the shopping list, right? And then that key space would refer to your list, right? So this would be the name of the app. That way you can share. That way you can share this one instance of Redis amongst multiple apps that you're building within your organization. And then this would be the first part of the key space, right? User MA fudge, and then the list that you're going to make. And then you would have a requirement that every list that you made had to have a unique name, right? And so the combination of the user's name and the list name is the business key that we're going to use to establish the fact that list is unique. So, if I may, L push onto my shopping list, beer, nachos, and cheese. Okay. And then I can do L range, 0, 1. And that just gives me the first two, 0 and 1. Okay, let's do a few more. Like, what does L index do? L index. Let's put in beer. That's not an index, right? So, but if I put in 2, that's going to be cheese. No, it's beer. Why is it? What's 0? Oh, cheese. Okay, so yeah, it's beer, nachos, cheese. Cheese is the first one. Okay, there you go. So let's do this. Let's do L push. L push. So on the left side, we're going to push, and we're going to push beer, nachos, cheese, and napkins. Okay, and then the index for that is 4. So L index 4. Nothing. 3. Beer. and then 0, napkins, right? So napkins is the first item on the list now because it was put on the left side, right? So if I do L range 0 minus 1, right? Napkins is first, cheese, nachos, beer. Because if I L push, the next one's going to go above napkins. So let's do this again. L push. And then now we're going to push, I need to buy oranges. Okay, and then I go L range, and then oranges is first. So if I L pop, and I just pop one of them off, I'm going to get oranges because that's on the left side. If I R pop, I'm going to get beer. Now if I get an L range, I'm going to have oranges and beer off my list. So see, I can remove from either end of the list if I want using push and pop. And this allows me to build stacks and queues as well as just regular flat out to-do lists that I might need to. Okay. Let's build a work queue. So maybe you have an app that needs to send text messages, right? So you can do something like this. You can say L push, and it's time to send a text message. So your Python app says, or your mobile app, someone says, I want to text my friend, right? So you push, notify me via text, right? You push that button. And then what happens is it does this, sends this to Redis. App, SMS, and then it might send the phone, the data, that's the key, app SMS, and then the value might be 555-1234 is the phone number, and then the message that it's going to send. It could be comma delimited, it could be space delimited. It says, welcome, please read this text. That would be the first text message. And then you could push to that same queue another phone number. And it might be, meet me for dinner, Johnny. Now let's suppose that our code that actually processes text messages is down. The app still works. So I go here and I push some other phone number. The app still works. What happens is they just sit in the queue. They just sit in the queue, waiting to be processed. Now we want to process these messages in the order in which they arrive. We don't want to do the ones that happened last first. So when the app to actually send the text messages comes back up, we can do this. That app would do pop app SMS. Just pop one. It would read that out of the list, and then it would then send a text message to this phone number with that data, right? And it's really just going to get this data back from Redis, and then it's going to use this data here to send the text message. And then when it's done sending that text message, it might pop the next one, and then send that message, and then pop the next one, and then send that one. And then it would try to pop the next one and get nil, and it would know that there's nothing to do, so it could sit idle and wait. And then maybe check again in 2 minutes or a minute. You see later that we can actually have it get notified when there's a message so that the app knows that it's time to ask to RPOP. So you don't want to sit here and poll and say, is it time for a message? Is it time for a message? Is it time for a message? Instead, what would be better is if you can get a notification from the app that says, yo, it's time to send a text message. Do your job. And then it would do an RPOP. Okay, and we'll demonstrate that in a little bit. But this is how you use Redis to combine multiple kinds of data structures to accomplish some very complicated things and decouple your application's architecture. Okay, let's take a look at ordered sets now. So ordered sets are another data structure that's available in Redis. Ordered sets are non-repeated collections of strings. Each string must be unique. Each string has a value. Useful for counters and dashboards. Similar to hash, except the way we can access it is different. So for instance, you could use ordered sets to track attendance. For example, I can say on 2021-4/8, there were 16 students in attendance. On 2021-4/15, there were 15 students in attendance. On 2021-4/22, there was 17 students in attendance. What I can't do is repeat this string. Key. This key, it can only appear once under this key. So that would allow me to say that this key has a unique set of values, which all have values that couldn't repeat. These values, I could have 16 in here twice. Now you might say, well, Mike, what about if I was doing an app that kept attendance like this? What about the actual students who were here and not? Well, I can store that under a different Redis key. Okay, that would be the way I would do that. I might have a list of students, or I might have a hash of students where this is the key. And then it would be course IST769 spring attendance, date, that's the key. And then under that key would be a list of students that were in attendance, the 16 students in attendance. That would be one way I could do it. Okay, so what you find with Redis is that you aren't building tables, you aren't creating one-to-many relationships. You don't think at all like that. You just think, here's the tools at my disposal: ordered sets, lists, strings, hashes. How can I use this to accomplish a task? Don't worry about storing the data more than once. I might have to do that, but that's the concern of the application. All right, so here's some of the common things we could do with ordered sets. We can add scores and members, and we can get a range with scores, and we can increment a score, and we can, add a score, a key, and if it already is there, it's just going to overwrite. It's very graceful. We can get a ranking, and we can also just return one value from that member. So you can see that this is a little different than a hash because it assumes that the value of the hash is a number, and because of that, you can do things like increment. And this ends up being pretty handy. So let's do an example with a leaderboard, a sales leaderboard. And I'll walk you through sort of like what the app might be doing, right? And how it might be fed its data as you're going through and designing this and architecting this in Redis. Okay, once again, I am out at the Redis command line here. And let's think about using ordered sets for something like a sales leaderboard. Okay, so you might have a screen at your office that just shows in real time who is selling the most widgets at your company. The screen can show anything as long as they're values. Maybe it's tweets by hashtag, right? It could be anything, any kind of leaderboard you want. So let's do just like sales. And I could do something like zadd, and my key will be app leaderboard. Now, in reality, it's probably not going to be app leaderboard. It's going to be something different. It all depends on how the app is architected, but this is fine for now. And then I am going to put in scores and members. So now I'm going to say like 100 sales went to Dave. And these could be, like I said, these could be tweets and hashtags. This could be like, you know, there are 100 tweets under the hashtag, you know, not now. And then there was 35 tweets under the hashtag love it. And you could be using this to track some campaign in real time, right? But I'm just going to do sales. So Alice has sold 100, and 120 have been sold by Sally, and Bill has sold 75. Okay. And let's say that, I don't know, 200 have been sold by George. Oh, I did that wrong. It's 75 Bill, 75 Bill, 200 George, like that. It's weird syntax. All right, now I can, let's take a look at the leaderboard. So I've added everybody in there. To start, I want to look at the leaderboard. Like, you know, this is like some JavaScript app, and it's got to query Redis to get the leaderboard data. All it needs to do is this, zrange, app leaderboard, 0, -1. That will get you the keys. If I want to see the values, I say with scores. And then I get back things I need to put to make my dashboard. Now, let's talk about what happens. Every minute, these values update, and they are fed from another app. So there's some analytics app that, you know, every time an order happens, it tallies it. And then after a minute, it then updates the leaderboard. So what might that look like? It would just go zadd. Up, Sally just sold 100. Or Alice, yeah, Sally sold 100. So app, leaderboard, you know, increment another 100 to Sally. And then, oh, I'll be dipped. George just sold another 10. And then let's show that leaderboard again. See, now Sally's at 220 and George is at 210. So you can make this leaderboard very easily. And again, think of that decoupled application architecture, because then you're thinking of Redis in the proper. So you have some data feed that is figuring out how many somebody sold, and you're sending that information to Redis. Like, let's say, whoops, I made a mistake. George didn't sell 10. I need to undo that and take away 10. Now he's back to 200, right? Now the leaderboard is once again accurate. All right. And you can manipulate the values on the leaderboard programmatically, and you can build these commands by once you know who needs to change and how they need to change. And then the app that shows the leaderboard is just running this every 5 minutes or 10 minutes and updating the leaderboard. So maybe this leaderboard changes once a day, but this happens every 4 hours. So let's pick on Bill here. Bill just sold 5 more. Okay. Then Bill sold another 10. Okay. Then Bill sold another 5. Then the leaderboard updates. Now Bill's at 95. Now you're probably thinking, boy, wouldn't it be great if when we add this to Redis, right? When I do this, if I can notify the other app to do this, that would be amazing, right? You can do that in Redis. That's what PubSub is all about. And that's why Redis has PubSub, so that you can integrate these things together and build a system that doesn't have to poll Redis but Redis tells it when it needs to go poll Redis. So Redis would say, yo, I got a message for you. And your app would say, whoops, I got a message. That tells me I better run Z-Range app leaderboard again because the leaderboard has changed. And then that gives people the illusion of real time because as the changes come in, the information is immediately reflected. All along, I've been trying to give you some examples of how you might use Redis to build data pipelines, to integrate between one app and another, to do long running processes with queues and things like that. But let's explore how a real app might be built just in Redis. So, there's an example out there called Retwist, which is a Twitter clone in Redis. And this will give us an idea how to make an app in Redis. And let's just do a demo of this and then see what is being manipulated in Redis as we work through Retwist. So what we're going to do when we do this demo is first we're just going to remove all the keys from Redis. And then we're going to go to the Retwist UI, and we're going to sign up and then throw a couple of tweets down. Okay, then we're going to see what the heck we have in Redis. And then we're going to try to find ourselves and find our tweets in Redis and see how that's managed. And then what we will do is we'll sign up as somebody else and follow the first user. And then try to find that in Redis or Retwist. Try to find that in Redis with the Retwist app, and this will give us a really good idea as to sort of how applications can be built with Redis data structures. And again, when you do it this way, this app will scale horizontally. Because you can run as many of the app as you want because all of the data is being managed by Redis. That's pretty handy. Okay, so let's go on with the demo here. All right, first things first, let's get rid of all of our keys with flush all. And boy, so if I do keys, there's no keys. So yikes, I just got rid of everything. Good thing my history is here because I think I'm going to want to have this leaderboard later. So I can always add that in later. That's good. But let's go ahead and do the Retwist example now. So I'm out here at the Retwist app, which I started from the Docker command line. And you can sign up and you don't have to worry about, putting in a valid username and password. They just have to match. So I'm going to make an account, mafudge, and then I'm just going to make a password here. You're going to see the password in Redis or Retwist or in Redis. So there, I just made a user. And, let's put in a couple of tweets. I like cheese. And let's put another tweet in here. Whoa. Hot sauce is so good. I don't do the Twitter, right? It probably shows. Okay, so I got a couple of tweets in there. Now let's go see what the heck Redis did. We're going to go to Redis Commander here, and I am going to refresh this. And these are only keys that exist because of Redis Commander. Now you'll notice that there is a couple of different data structures here. So I have a string next post ID, and then I have a string next user ID. Don't know what those are all about. Then I have a hash for auths. Okay, this must keep track of who's authenticated. So this user is authenticated, true. And then here's my posts and post. So I also have a list, and this list keeps track of the timeline in Redis, and it says 1 and 2. And I have a user and a users. So let's explore this. So I have users, and it has MA fudge. Okay, and then I have user star, and in here there is a hash for user 1, and user 1 is MA fudge. And I have a key. I have a key of username and a value of MA fudge, and a key of password, and a value of testing. And I also have this auth here, and you'll see that I saw this auth 0A 0FA. I saw this same auth over here. Right, so that must store my session. So it's very interesting. Like in the user's hash, it says MA fudge is value 1, and then under the user key, there's a number 1. So that's how we keep track of users. I make another user, they're going to be 2, and there's going to be 2 hashes in here. Username, value 2. So this hash keeps track of the users under this key space of user star. For example, let's make another user. So I'm going to go back to retwists. I'm going to log out. I'm going to make a new user. This user is going to be Bob. And then let's put in a password, something. Let's create an account for Bob. Okay. Now, let's go back and look at Redis again. Refresh. So now in users, I have 2 users, MA fudge, Bob. In the hash, there's 2 fields, MA fudge, Bob. So these are the keys. These are the values. And then in user, there's now 2 key spaces, 1 and 2. Right? So this is almost like a header that's used to keep track of these 2. And then there's a list that gives you an ordered list of these users. So Mike Fudge was first, or Mike Fudge was older than Bob. Bob is newer. Okay, now let's look at these posts. So in posts, I have a list, and this list represents all the posts. And there's just 2 posts, and if I go to post, there's 2 hashes. There's my 1 tweet, I like cheese. There's my next tweet, whoa, hot sauce is good. And if I go back to the app and look at the timeline, I see the 2 tweets that are in the timeline from the world. These are like global tweets, right? So how does this timeline get built? Let's go look at Redis. I got this timeline here, right? So let's go back and tweet as Bob. Let's go back and tweet as Bob now. So we're Bob, home. What are you doing? I also like cheese. Update. And while I'm at it, let's follow somebody. Follow this user. So Bob's going to follow MA Fudge. Let's check that timeline. I got I like cheese first, then whoa, hot sauce is good, then I like cheese. Let's go look at it in Redis Commander. So under posts, there's 2 lists. This is Mike Fudge's posts. These are Bob's posts. Mike Fudge's posts. Bob's posts. Why is the key 1? Where's 1? Well, that's user 1 is Mike Fudge. User 2 is Bob. So again, this is post, and then the 1 is the user ID. And then post here, these are the post ID, right? So again, this table, if you will, this collection or data set tells you which numbers, 1 and 2 of the posts. 1 and 2 belong to Mike Fudge. For user 2, 3 belongs to Bob. And then the timeline is just a list of all the posts. So this allows you to see your own posts, right? To see your own posts, you're really just looking at this list. And then from this list, it says just get post 3. And then it goes over to here to post 3 and gets this here. And that's what you see. So again, let's go back. That's Bob's posts. So let's make a couple more posts. Let's do, there's one post. There's a post. And there's a post. Okay. So there's 3 more posts for Bob. So Bob has 4 posts now. Go back here. Refresh. And now there are 6 total posts, right? And the timeline has 6 posts. And 4 of the posts belong to Bob. 3, 4, 5, and 6, those are Bob's posts. And if I want to see any of them, you know, what does post 6 look like? There it is. What does post 5 look like? There it is. What does post 4 look like? There it is. Okay. So this is how you might build an application in Redis. It's very contrary to how you might think of building an application in a relational database, right? Because you don't have things like tables and foreign keys, but you do implement something similar, right? This post table is really like user posts. This user, hash is really users, and this post is the posts. So this is just 1 hash per post. And this is 1 hash for user. So for user posts. So I am going to make a post in Redis Commander and then show you that it's going to show up in the UI. All right, here goes nothing. So every post has a user ID, a time, and a body. Okay, so I'm going to do that now. I'm going to add a new post. This is going to be post 7. And it's going to have a user ID of 1. That's going to belong to Mike. User ID 1 is Mike. I don't know how to do a timestamp, so I'm going to just cheat and take that timestamp. So let's add a new field to the hash called time. And let's just make this a little later. There you go. And then I'm going to add a new field. What is the other one? It's called body. Body, right? Add a new field, body. And this is going to be internal, like tweet, manual tweet. Haha. There. Now I'm not done. It's a post, but I need to make sure it gets put in the user's post and the user's timeline, because right now, retwists won't know to find it. See that? It doesn't show up. Because what makes it show up here is this timeline has post 7 in it. It doesn't. So I'm just going to go here and I'm going to add a new value. And it's going to be 7. I wonder if I can... I didn't set the right index on there, but that's okay. Let's see what that did. And there it is. Manual tweet shows up. Okay, the time's all off, but whatever. Right, there it is. Pa-da! And then if I wanted to show up in Bob's timeline, which would be wrong, because it's not Bob's tweet, it's Mike's tweet, but I guess I'm logged in as Bob, so maybe I should change this to Bob. Let me do that. Let's change this to Bob. And let's go back here. This says MA Fudge, right? Now it says Bob. Aha! And then let's do this. Now let's put it in Bob's personal timeline. If I go over here and go home, I don't see it there. It's not there. In order to make it show up here, I need to go and add it to this one, right? Because this is Bob, and 7's not in there. So I need to add a new value. I wonder if I could change this to go to index 4, and then add new value. Oh, R push. That's where I went wrong. And then this would be a 7. There we go. Now I got it in the right spot. I did an L push. That's where I went wrong before. Or maybe I should have done an R push. I don't know. I did the wrong push. But this is why I shouldn't be hacking it this way. But let's see. Does it show up here? That's, I guess, the important thing. And there it is. The manual tweet shows up here. So I did it. And this gives you a great example of how to build an application in Redis, right? You're going to think a lot differently about how you do things. When you do it this way, you're not going to think very relationally. You have to think given the data structure you have. Now, one last thing is Bob is following MA Fudge, so I can see that here. Bob following MA Fudge. MA Fudge has one follower, Bob. So this is a sorted set used for building a leaderboard, and that is kind of what you see here. I'm following one person. Bob is following one person. MA Fudge has one follower. So again, what you see over here is being built using these lists over here. Cool. So that's, in a nutshell, the Retwist app and how it uses Redis to store data. And again, what makes this really awesome is I can have 10 instances of Retwist running, but they're all talking to the same Redis database on the back end. And because all of my application state is stored in Redis, it will scale very well. Let's take a look at PubSub with Redis streams. So basically, when you have a PubSub model, you have a channel or topic in the middle, and the client sends messages to the channel, and the other client receives the messages from the channel. And this is not something where you have to pull. These notifications are pushed to you, so you won't have to do anything on your part other than listen or wait to hear for a message. So streams are for real-time movement of data. The subscriber sees the messages as they are published. So the moment the message is published, we see the message. And these are sent to what's called a channel in Redis. In other PubSub models, they're sometimes called a topic, but in Redis, they're called a channel. And any subscriber to the channel sees the data. So this allows multiple subscribers to take different actions on the data. One subscriber might log the data or save it to a database. The other subscriber might actually send an email or something, depending on what the nature of the information sent to the channel is. And any subscriber to the channel will see that data, as I said before. And this is useful for sending real-time messages. So some of the obvious use cases is, chat, right? Chat. But you can also use it in a microservices architecture to decouple services. Okay, and I will give you an example of that. We can do the exact same thing we did with sending SMS messages, but instead use a PubSub so that someone doesn't have to keep asking Redis to pull. We can also do the same thing with our leaderboard, so someone doesn't have to ask Redis to update the leaderboard. So here are the pub sub commands. We have subscribe, publish, channel message, subscribe channel, unsubscribe channel. Pub sub channels will list all the channels. P subscribe will subscribe to all channels matching a pattern. And P unsubscribe will unsubscribe channels matching the pattern. And again, you might have a key space that is unique to build a channel that can subscribe to like all things that do messaging, right? So it doesn't matter what app is doing messaging. If you set the key space up right, you can subscribe to any kind of message from any of your apps that will send an email, and then you can have one service that processes all the email for you, regardless of which application needs emails sent. And now you're really taking advantage of microservices architecture. All right, how about a demo of pub sub? I'll try to get as detailed as possible with this after I do a really, really basic example. Okay, here I am out at Redis again, and I have two windows going. So I have window 1 over here, and I have window 2 over here, and I'm going to set up a basic pub sub setup. So let's start with subscribing, and I'll subscribe to the channel. Let's call it chat for now. And over here, I am going to publish to the channel chat. Let's publish the message, hello there. You'll see that the subscriber sees that message, and I can publish another message later on. Then the subscriber sees that message. It's important to note that when you're doing pub sub, that really I would need 4 of these connections to Redis. I would need one to publish the message from one client, and then another window to listen for messages that come back if I'm a publisher and a subscriber. And then the subscriber needs to listen for messages, and then probably would need another client to execute commands based on that subscription. So, excuse me. As an example, let's go back, and do I have the leaderboard here? Let's go back to that leaderboard example. So there's my leaderboard. I got Bill backwards again. 75 Bill. Okay, and then, so this is on this side, this window over here, this is the one that gets a feed of changes to the leaderboard. Like, oh, all of a sudden, look at that. Bill just sold 5 more. And then this Redis client over here is the one that's going to display the leaderboard. It's going to do that Z range command. Right? And I probably want the scores. So that is going to get the scores so that it can display the dashboard. And then this is the one that keeps track of the changes that are made. And now Sally's 125, right? What I want is this client to send a message to this client so that this client knows it needs to do this. Now, I could do something where I say, you know, publish. Let's suppose I have a channel called I publish to a channel called App Leaderboard Notify. And I publish to that Z range. I could publish the Redis code that I wanted to execute. You want to avoid in your messaging sending code through your messaging and then blindly in your client executing that code. That's a recipe for getting hacked. Okay, exposing a security vulnerability. Because if I don't vet the commands that I send as a message, right? Don't confuse code as data, right? You can come up with your own protocol for interpreting data as code, but do not ship raw code as data. So I should never send as my message some Redis command here. That's a no-no. So no Redis command. But what I could do is in the notify, I could say refresh board, something like that. That would be what I publish. And then this client would subscribe to App Leaderboard. Okay. And then over here, what would happen is I would Sally would go up 50. And then I would say, hey, leaderboard, refresh yourself. And then this gets a message that says, yo, it's time to refresh. And then this client, in another window that it had, in another connection to Redis, because one connection has to listen for messages, the other connection has to say, oh, I just got a message. Now I'm going to read Redis. I'm going to read Redis, get my scores. Right? So again, you have to kind of envision this because I really need 3 windows here, but I just don't have the real estate to do 3 windows. But again, what happens is the client over here on this side, on the right, this client receives a data feed that says, up, Bill just sold 100. And then step 2, that client would say, let's send a notification out so that people know. Everybody who subscribes knows that data has changed. And then over here, the subscriber says, oh my gosh, I just got a message that says refresh board. See that? Refresh board. You didn't see it? Went too fast here. There it is again, refresh board. And then when I get that message here, that Python app or Node.js app or whatever it might be, that would in turn run this Redis command to get the new leaderboard data. This one here. Then it would get the new leaderboard data and then draw the leaderboard. So that's how you would integrate pub sub with Redis. You're going to have to listen for changes that come over the pub sub channel, and then based on the data that you get in the channel, take an action. So this action, refresh board, runs this. Again, what you don't want to do is publish. You don't want to publish. Let me see if I can do it. This is what you don't want to do. You don't want to publish to the leaderboard this command. You don't want to publish that to the leaderboard. And then on the client, blindly take the message and run it in Redis. That's a no-no. We don't want to do that, again, because you're confusing data with code. You don't want to mix data and code together. It's okay to send it a message, like the message might be refresh board, and then your code can look for refresh board, and then when it sees refresh board, it runs this. But you don't want to broadly send open-ended commands or codes from one system to another, because by doing that, if someone can intercept this messaging, they could send a message like this. They could send a potentially dangerous message. If I'm blindly just executing whatever comes after here, then I get this message that says flush all, and I delete all the keys. Whoops! I just deleted the entire Redis database. Okay? This is why, again, you don't want to just broadly interpret data channels as code and then execute the code. This allows for a remote execution vulnerability to be easily implemented by someone else. So bottom line, with messaging, we generally aren't sending around commands or code. You can certainly send around data that gets interpreted as a command by your code base, but then you control the code. There's no situation where it's just blindly executing the data that it sees without knowing what the data that it sees is going to do. Okay. But anyway, that's PubSub, and that's an example how you might use PubSub. Again, you could use this for a variety of things. You might have a channel here that, over here on this, in this window here, you might have send an email, right? So you might publish to app email, notify, and then give it all the data to send off an email. And then the subscriber over here, when it got that message, it would read the data and then the email. Okay, so another example of how this might be used in a microservices architecture. All right, let's wrap up with a view of the Redis Spark connector. So the Redis Spark connector supports hashes only. So you can not issue arbitrary commands with Spark, but what you can do is treat hashes under a common key space as a data frame in Spark. So what happens is when you write to Redis, you will get a special _Spark key. And inside there will be some schema data, some metadata about the schema. And when you read data from Redis, you must include a schema or infer schema in Spark in order to figure out what the data types are of the hash values. So let's do a demo of this as our last demo of the day. I'll show you how to read and write data from Spark. And this is pretty useful. It's not really, there's not a lot of general purpose stuff you could do with Redis in Spark, but it is kind of nice to know that you can treat hashes with common keys as tables. That is useful. All right, I'm out here in Spark. And I am going to, I already ran my Spark connector. I believe I ran my Spark. Maybe I should run it again just to be sure. Up at the top, I have my connection code for Spark. Probably should run that. And you'll see that I have to connect to Redis and then include my Redis jar here. I'll run that first. Okay, then I could go down and do this stuff. So this will just pretty much read a local file into a data frame. So this is nothing spectacular, just reading in our stocks data into a data frame. And now I'm going to write this to Redis. So, this is, I got to use, like just about all the other databases you write to, custom format, overwrite. Stocks is going to be the common key space. And then I have to specify which column in here is going to serve as the business key under that key space. So the key is going to be stocks, Twitter, stocks, Tesla, stocks, Netflix. Why? Because I said I want the key column to be symbol. And symbol is this column in the data frame. Key column symbol. So I'm going to run it. It's finished. It's already in Redis. Let's go to Redis Commander and do a refresh. And you'll see now there's a Spark folder, first of all. And in that Spark folder, there is a stocks folder. And in here, there's a string. And in the string is just a, this is just a binary representation of the schema. Okay. Just some Spark metadata. You really don't have to pay attention to it. In stocks, I now have a hash for each of these, and the field is the price, and the key is the name of the symbol. And why is that? Because again, up here, I chose key column symbol. So if I go back here or even go here, I can do something like, you know, H get stocks Apple value. And I got to do it right. I think it's AAPL like this. Oh, is it? Let's do this. Let's do keys stock. Okay, so it's stocks. Yeah, I did it right. Stocks AAPL. So let's do hget stocks AAPL. Price, I think is the, it's price, yeah. Yeah. So if I do hget all, that eliminates me having to figure out what the name of the value is, but it's price. So there's me getting one of the stocks. So see, this was put in there by Spark. Okay, let's do the opposite. Let's read something into Spark from Redis. So this is me reading the same thing but this is not me reading the same thing in. This is me reading in a bunch of students. So you might say, well, do I have a student key in here? I did at one point, but I probably don't now because I got rid of it when I deleted all the keys out. So this probably won't do anything. Yep, nothing in there. But what I can read out of here is when I was fooling around with retwists, right? Retwists made these tweets. Where was that? I got posts right here, post, right? So if I go post, and what do we want the key to be? We want the post key right there. 1, 2, 3, 4, 5, 6, 7. So if I say, let's make this post, and then the key column is going to be called ID. And then let's infer a schema from that. Let's see what we get now. Okay, now they are not students. These are retwists. But it works the same way, right? See how fast that is? It's incredibly fast. So this is a user who made the post. That's the timestamp of the post. That's the ID of the post. The ID of the post is what we chose to be the key column here. And then this is the body of the post. Body, user ID, and time, those are all the actual parts of the Redis hash, user ID, time, body. The value 1, 2, 3, these are the ones that are assigned as part of the global key. Post 2, post 4, post 7, right? And if I go back here, you'll see post 2, post 4, post 7. Post 7 was that manual tweet, right? Manual tweet. Okay. So that's how it works. I cannot use Spark to read out lists or, ordered sets or anything like that. It will only read and write hashes under a common key. So if you think about it, those are the only things that are really tabular in Redis, and so that's why those are the only things that are actually compatible with Spark. Okay. Now, there's all sorts of other libraries that you can use if you just want to read and write Redis in Python and things like that, or in PHP or C#. There's lots of great Redis libraries out there, but again, we're really just mainly focusing on Spark in this class. So I wanted to show you how to be able to read and write that back out with Spark. Again, the important thing to note is you got to put in a pattern, key pattern, which part after this key, what are we going to call it in the data frame? I'm going to call it ID. And then I'm going to guess what the schema is of these. So if I were to go down here and do, retwist, hosts, and then I do print schema, you'll see that it takes an educated guess. Well, basically they're all strings, so I guess it wasn't that educated of a guess. But once I get it in here in Spark, I could easily manipulate it, right? So that works to my advantage. Okay. Okay, let's sum up what we learned about Redis. So we saw that Redis is a key value database with different types of data structures that can be stored under the value. Redis supports 2 storage models, RDB, which is a snapshot model, and AOF, which is more along the lines of a transaction log. Redis has 2 modes of scalability, CP and AP. It can be single master or eventual consistency. Redis has a variety of data structures that we can implement under the key. For example, just plain old strings, lists, hashes, ordered sets, and pub sub data structures. Redis hashes can be accessed through the Spark data frame API, and what comes back looks a lot like a data frame. And so basically, if you have a hash with common value, with a common key namespace, that can be converted quickly and easily into a Spark data frame.